Hi guys, it's Ajanette, and we left off talking about the stages of development. So over the course of the semester, we're going to go through developmental periods, and I have arranged the course so each module kind of addresses a developmental period. And a developmental period is just a chunk in the lifespan, and there's kind of common themes in the two developmental periods that I may merge together in a module. So in prenatal development, from human development, we start looking at how we change from conception. And there's actually going to be a little bit of information about genetics before conception that lead up to prenatal development. So we're going to take you all the way through how the baby changes throughout the course of pregnancy. Then infancy, prenatal and the neonatal period. Neonatal is an infant immediately born. And so we're going to cover that period together. Then we're going to go over infancy, which is about, the first year of life, toddlerhood. As soon as they start to become mobile and they're walking, they're going to be in toddlerhood. So you're going to find from about 1 to 2 years of age in toddlerhood. Early childhood is going to cover 3, 4, potentially 5 years of age for early childhood. Middle childhood is going to be that elementary school period, that's 6 years to maybe 11 or so. Adolescence really starts, it doesn't have specific ages. It's really going to start about puberty-ish. So figure middle school and high school is going to be included in adolescence. Then emerging adulthood is not seen in all cultures. We are a privileged culture in that we're in a developed country with a lot of wealth. And there's a lot of technological demand for careers these days. So there needs to be some educational training and background. And like many of you who may be in this period where you're still living at home, but you still take on a lot of adult roles and responsibilities, but not completely financially independent yet, that emerging adulthood period allows you to kind of have a smoother, easier transition from adolescence into adulthood. People such as myself, who became a mother at 18 years of age, I really didn't have any emerging adulthood. I just had to break out and kind of break into that role and support myself and my son. Then young adulthood or early adulthood is going to be the 20s to 30s. Middle adulthood is going to be the 40s to 50s to about age 65. And late adulthood is going to be 65 and above. And we're going to talk about different segments within the late adulthood period as well. But those are kind of the general time frames that we're going to be looking at over the course. Finally, I'm going to end with some scientific information. So human development is in fact a social science. We do adhere to the scientific method that includes identifying a research question, formulating a hypothesis or an educated speculation as to the outcome of that research question, designing a method or study in such a way as to be able to answer that research question based on empirical observable data, collecting that data, so we're actually conducting the study and collecting the data, and then based upon the data and our analysis of that data, we're going to be able to draw some conclusions. Was our hypothesis accurate? Can we support or negate or reject that hypothesis? And then we want to try to explain maybe what within the research design or what within the world might be contributing to the outcomes that we were able to find. And then, of course, we want an opportunity to kind of feed that cycle of research where once we draw conclusions, it kind of feeds into the next loop where our conclusions might help us to, may lead to another research question. So you quite often find that studies end with suggested future areas for research, and then the cycle continues again, and that's how we continue to build sequentially on our knowledge base. So with the scientific method, when we're talking about our research question, often that starts by doing a literature review, and we might have existing research or our own personal theory or observations, and we want to test those in an observable way. The hypothesis also can be fed by the research question based on the literature review, based on what we already know in the research, what studies have already shown us. Then we have some idea, or if we have a theoretical framework for our research question, we have some idea as to what expected outcomes might be. So that's going to dictate our hypothesis, which then will dictate our research methods. We're going to choose an appropriate research method or design that fits with our proposed question and hypothesis. Not all questions are set up for certain designs. For instance, an experiment requires a carefully controlled scientific approach, and it requires random assignment where each participant has an equal opportunity to be in either a control group or an experimental group. Some questions don't naturally fall into that type of random assignment framework. Like if I want to study the effects of rape on self-esteem, I can't randomly assign victims to either a control group or an experimental group. And so therefore, by nature of the research question and the potential hypothesis, I might need to lean toward a correlational design. So I'm going to choose my method and design based upon that hypothesis and research question. And then I'm going to collect my data. I'm going to start with a larger population, like let's say I want to understand the effects of video game on aggression in childhood. So my larger population is childhood, but it's unreasonable that I'm going to be able to study every single child in the world. Even if I narrow it, I can't study every child in the United States. If I narrow it still, I can't study every single child in San Diego. If I narrow it still, I can't study every single child in Oceanside. So what I have to do is I actually have to draw a subset of that population that can serve as the sample in my study. And the whole point of inferential statistics is if I'm adhering to the scientific method, I conduct a study, I'm able to use those statistics to draw inferences about the larger population based on the results that I get from my sample. And so I liken this to like 31 flavors. It's really important that your sample's representative. If I want to try Rocky Road ice cream, that whole 5-gallon tub in their freezer is my population of ice cream. I just want to try a sample to see if I can draw conclusions about that flavor of ice cream. If they give me a sample that only has ice cream on it, the chocolate ice cream, I really don't know what Rocky Road is. If they only give me a nut, or I don't know what Rocky Road is. If they only give me a marshmallow, I don't know what Rocky Road is. So my sample needs to be representative. So on that little pink spoon, I need some ice cream, a nut, and a marshmallow to truly have a good understanding and to draw reliable conclusions about the larger tub or the population. So we'll talk more about some scientific principles that relate to that. And then finally, drawing conclusions, we're going to use those inferential statistics. And when we publish, it's submitted through a peer review process. So it's reviewed by a panel of experts that had that scientific training and background, and they can ensure that we really adhered to quality procedures when conducting our research question. And ultimately, our results can lead to maybe supporting a theory, negating a theory, modifying a theory, or other changes in the research. When we're going to do a study, most institutions like medical institutions, educational institutions, they have what we call institutional review boards or IRBs. And those are panels of individuals where you submit a research proposal, and kind of like we do after you've submitted your study, you submit it for peer review. This is kind of like a peer approval process for the study itself. And they want you to submit kind of a general proposal of your theory, of your study, including your research question, your hypothesis, and your proposed design. And they also want you to submit the materials that you propose to be using in the study. So once we have our sample, and we know who we're going to be working with, they go through a certain process. First, it starts out with they have to have informed consent. They participate in research based upon their consent and willingness to participate. And then they have to be assured that their information is going to be confidential. Often we don't have their name tied to the data directly, and we report and analyze the data as an entire group rather than looking at each individual's data. And so in the beginning, they have an informed consent where we go through and kind of explain what the general purpose is and any potential harm or implications, that they're going to be protected as far as their identity. We conduct the study, and then after we give them a debriefing. And the debriefing statement, it's a little bit more detailed explanation as to what specifically the study is looking for. If we used any deception, like if I'm going to do a memory study, it's really hard for me in the informed consent to tell them what I'm looking for, because that could affect their behavior or performance during the study, and my results may not be valid. So in the debriefing, I'm going to now, if I used any deception or trickery, I'm going to now reveal that in the debriefing so they know what, in fact, I was specifically looking for. Now that it's after the fact, it's not going to influence the study at all. And then they also are told any harm or resulting impact that may have that they may be exposed to, and then who to contact for results. So some of the methods that we use: questionnaires, where we gather a large amount of information. We can gather it from a large amount of people, usually with closed or open-ended questions where they might have to provide a narrative. You can use interviews, which gives you qualitative information for your questions. You can do observations, which you're going to do in the course, where you go and you do an objective observation and you're tracking data and behavior and counting certain behaviors, and then you're doing a report or analysis of it. Ethnographic research, where you're going to actually go and study different ethnic groups, and you're going to learn kind of a larger scale observation of behaviors and patterns that emerge within a particular cultural group. Case studies, often where there is something unique about an individual or a small group of individuals. Like, let's take, for instance, HM, who suffered a brain injury, and then a lot of researchers came from around the United States and observed him and did studies with him to understand how his brain injury impacted his personality and his memory abilities. So a very unique situation where we got a lot of information for him, but it doesn't generalize as well to the to the general population. And then biological methods, like you might want to do brain scans or blood draws, and look at maybe some of the genetic components of various behaviors or personality traits. So there's advantages and disadvantages to each of those populations. Questionnaires can be great, and they let you get a lot of information. Interviews, it's really qualitative information, but to try to code it and find similarities can be more time consuming. Case studies can be very rich and detailed, but hard to generalize, like I mentioned. So biological can be very expensive. And then we have experiments, which are very carefully controlled studies conducted by researchers, and they are the only way by which we can identify cause and effect. The challenge with those is not all research questions can be submitted to an experiment because of the rigorous control requirements of an experiment. And so they may not act or reflect real life, in that it creates kind of an artificial situation. A natural experiment is something that's occurring in kind of the natural world, where you can separate groups. It just naturally sets itself up for an experiment. Like some twin studies can be natural experiments, especially if they've been separated. I was reading about twins, one that grew up in Germany and one that grew up in Israel, and both Jewish, and that was kind of a natural experiment to see how their environment and their upbringing influenced them.